How do we actually design the rules for our society? The rules for how we vote, how we regulate industries, or even provide public goods. For a long time, there was this dream that economists could be social engineers, that they could design perfect systems for any goal imaginable. But then, a Nobel-winning discovery came along and showed everyone a hard mathematical limit on what's even possible.
So, you gotta understand, before the 1970s, economics was mostly about analyzing systems that were already out there. But as Eric Maskin points out here, a totally radical new idea called mechanism design just flipped the entire script. Instead of just studying the machine, the question suddenly became, could we build a better one? Could we literally engineer our institutions from the ground up to achieve any social goal we wanted?
All right, so here's our game plan. First, we're going to explore that initial, really optimistic dream of the economic engineer. Then we'll hit the massive roadblock that came up, what's known as the implementation problem. After that, we'll look at the genius test that helps us separate possible goals from impossible ones, see how this set new boundaries for our ambitions, and finally, understand the new foundation this whole idea built for modern economics. Okay, so let's start with this incredibly optimistic dream, a real game changer pioneered by the economist Leonid Hurwicz. And, this was a huge shift in thinking. Economists went from just being observers to potentially being the architects of society. The core idea was that if you could clearly define a goal, let's say clean air for everyone, or a truly fair voting system, you could then design the perfect set of rules or a mechanism to make it happen. This mechanism would be so clever, it would use people's own self-interest to guide them toward that collective goal. It's almost like building your own invisible hand.
But you know how it is. That optimistic dream? It was about to collide head-on with a pretty profound challenge, a reality check that was delivered by Eric Maskin.
So Maskin comes along and asks this just devastatingly simple question. He wasn't asking if we could get close to our goals. He asked, can we design a completely foolproof system, a mechanism where people just acting strategically in their own self-interest would always and unfailingly lead to the best possible social outcome? Was every single desirable goal we could think of truly achievable? And the answer, it was a big resounding no. Maskin actually proved that there are fundamental mathematical limits to what we can design. Some perfectly reasonable, desirable social goals are just impossible to guarantee once you account for the fact that people act strategically. Now, this wasn't just some small correction. It was a structural rupture that created an entirely new field called implementation theory. Okay, so if not everything is possible, that naturally leads to the next big question, right? How do we even tell what's doable and what's just a pipe dream? Well, Eric Maskin didn't just point out the problem, he actually gave us the tool to solve it. Let's make this concrete with a simple example from Maskin's own Nobel lecture. So we've got two people, Alice and Bob, and they have to choose an energy source. In this first scenario, state 1, they're both mainly focused on the present. If you look at their preferences, the best social compromise, the outcome they can both live with, is oil. But now, let's say their whole mindset shifts. In state 2, they get more focused on the future. Their preferences change. Now, the new best social outcome is gas. But here's the crucial part, the detail you have to catch. Look at Alice's preferences. The old best choice, oil, has now fallen in her personal ranking. That little detail is everything. And this brings us to the core brilliant idea, Maskin monotonicity. It's basically a simple logic test. It says that if an outcome was the best choice and then people's preferences change, as long as that original outcome hasn't fallen in anyone's personal ranking, then it must stay an optimal choice. If a goal fails that simple test, we call it non-monotonic. And that right there, that became the essential litmus test. Monotonicity is what's called a necessary condition. If a social goal you're trying to achieve fails this test, if it's non-monotonic, Maskin proves that it is fundamentally impossible to design a system that can guarantee it. It's not just that it's hard, it's mathematically off the table, period. So what was the impact of drawing this new boundary? Well, it completely redefined what economic engineering could ever hope to accomplish. Maskin's work forced a monumental shift in thinking. The early dream, you see it on the left, was basically, hey, let's define a cool goal and start building. The new reality, on the right, is, hold on. First, let's test if our goal is even possible. It turned mechanism design from a kind of hopeful art into a rigorous, hard science, one constrained by the cold, hard realities of strategic behavior.
And the ripple effects of this idea were just enormous. I mean, implementation theory provided a whole new foundation for designing institutions across the board. We're talking about everything from how we design voting systems and government regulations to the complex auctions we use to sell public assets like radio spectrum. All right, let's bring this all home. What's the ultimate takeaway? What did we actually gain by discovering the limits of what's possible? This is why this all matters so much. The central challenge of designing a good society isn't just about having good intentions. It's about building systems that actually work, despite two massive, unavoidable constraints: strategic incentives, the fact that people act in their own interest, and private information, the fact that we can never really know what's in everyone's head. Maskin's work didn't give us a map to utopia, but it gave us something much more valuable: the architectural blueprints for what is actually possible to build. And this leaves us with a really provocative final thought. If a simple choice between a few energy sources can be mathematically impossible to design for, what does that mean for our biggest, most complex ambitions? Think about the major social or political goals we're all striving for today. Could it be that some of them are fundamentally, mathematically impossible to achieve?